Hello everyone, welcome to the third session of ZEISS Micro Minute. I'm coming to you live from the ZEISS Microscopy Customer Center in Dublin, California, in this very beautiful building. My name is Amita Gurur and I'm going to be your presenter today. So for today's topic, we are going to look at automatic tissue detection on the ZEISS Axioscan 7. So very quickly, if you have questions live during the session, please feel free to put on all your questions in the chat and we will try to get to all your questions at the very end of this session. So let me switch screen and you should be able to see my screen. Yep. All right, so for today, we are going to talk about automatic tissue detection on ZEISS Axioscan 7. So the Axioscan 7 is our slide scanner, and one of the many different things it can do is automatically detect tissues on your slides. And during this session, we will cover this very new module that has really revolutionized the way we do slide scanning here at the Microscopy Center, which is based on image analysis and AI-trained models. So I will be showing you a couple of examples, and we'll take a look at some of these workflows at the microscope as well. So before we jump into this example, let's look at some of the current ways of how tissue detection is done currently. Yeah. So if you have sections which are brightly stained, right? These are bright field sections. And so if you have a nice bright stain, the Axioscan does an awesome job in just delineating these sections with this green border that you see around every section, right? So each section is labeled as 1, 2, 3, 4, and they just pop right at you, and there is absolutely no, challenge for the Axioscan to detect such kinds of tissues. So this is your bright field sections. Another method would be if you had fluorescent sections, and these are sections that are not as bright, right? So if you look at my slide that is down below in the screen, so these are not easy to see. If you hold them against light, yeah, you might be able to faintly see the sections, but not as bright as the stained histological slides. So for this, one of the methods that we use is we use a Sharpie, and then we draw a region around the tissue just on the cover glass. So you hold your slide, use a Sharpie, and then you draw those sections. And then when you try to scan on the Axioscan, it'll delineate, as you see, that green region around the tissue, and it'll scan everything within that marked region. Now, the downside to this type of method might be that it's scanning a lot of empty region, right? So you're not as tight to the tissue region. And we also risk with focus points that might be laid automatically outside of these tissue regions, right? So you would then need to drag them in. Well, it has its, downside, but it's also a tedious method. So we will look at some of other ways that we could, use image analysis to not have to do Sharpie method. Another method, before we get into that, is you could use fluorescence on your tissue section. So for example, in what you're looking at is fluorescence using DAPI. So it could be autofluorescence, or it could be any brightly stained fluorophore on your tissue section that you can utilize with a low mag objective. You scan the entire slide with that, and then utilize the intensity of that fluorophore in delineating these tissues. So that slide that you see, these are coronal sections. Very difficult to pick up, and we definitely don't want to be manually drawing these sections out. That sounds very painful. So anything that will alleviate our time at the instrument to make it as automated as possible, that would be a method of choice for tissue detection. So while this method works really great, it does have the, you might bleach your sample. So we definitely want to look at methods that, move away from fluorescence entirely, if that's even a possibility, right? So the method that I'm going to be talking about is also, I'm going to get to it later, but then I also wanted to mention 𝗠cie𝗿𝗶𝗹𝘀, which some of our customers utilize this staining method. So you can stain your sections with 𝗠cie𝗿𝗶𝗹, fluorescent sections, and this helps you in detecting your tissues. So while these are fluorescent sections, we understand 𝗠cie𝗿𝗶𝗹 does not interfere with fluorescence. So this is another great method for tissue detection. So moving on, this is where the excitement begins in this session. In the next few minutes, this is what I am personally really excited about, because everything we spoke about so far, the marker method, the fluorescence DAPI preview method, so on and so forth. How can we avoid bleaching our samples? How can I, as a human, not have anything to do with drawing, marker method or Sharpie around the tissue, so on and so forth? So what we have been doing recently is utilizing these AI models that have been created on our 𝗍𝗻𝗀 cloud platform. So you can create models and utilize those models as image analysis setting within Zen software. So you might be thinking, which version of Zen should I be using? So it's beautifully integrated, this module called custom sample detection in Zen 3.9 onward. So if you have any Zen version starting 3.9, you should be able to seamlessly integrate image analysis settings into your scan profile. So it's not something that you do outside. It's an analysis setting that you integrate in the scan profile, and then you start scanning. So what played in front of you is essentially, I asked myself a question: can I just detect subregions within a brain section, right? That would be so awesome if I'm able to detect just a region of the brain section utilizing AI. So what you saw playing on the screen is we have learned the more images you feed into the segmentation program, the better your segmentation outcome is. So in this example, it is essentially a bright field slide, Cox stained 𝗁𝗁𝗍𝗁. So basically, these sections have beautiful 3D 𝗁𝗁𝗍𝗁 segmented neurons that one can see, but you can paint these regions that you want to identify on the 𝗍𝗻𝗀 cloud platform and generate a model. And what I'll show you next is a preview of the outcome before we go at the system. So basically, imagine just detecting subregions of your tissue, right? What typically is done so far is you are detecting the entire tissue. Like we saw in the very beginning of this presentation, you can delineate your entire tissue section with that green border. Now, what you see on the top is these brain sections that have been detected by the default threshold-based tissue detection model. Now, what you see below is us utilizing these models that we generated on the 𝗍𝗻𝗀 cloud platform, all of the AI models that I'm talking about, one very specific for detecting the hippocampus. So isn't that exciting that you can just detect the hippocampus on your brain section? Now, what does this mean for the user? For the user, this is really efficient data handling, because you don't want to be scanning regions anything other than what you need. This when I personally saw this result, I was just blown away. This was just amazing, just to be able to detect subregions within your tissue. So let's actually go to the instrument and try to play this live. So if you're familiar with how the Axioscan scanning works, is I have started a preview scan. So I selected a slide. I've selected a profile from the drop-down menu. You must be very familiar, right? You just select a profile. And then I started, I clicked on the button that says preview scan. So once that's done, it takes around 16 to 18 seconds, and it gave you a preview of the detected hippocampus regions, right? That was done on the preview image that was generated with the preview camera, right? So I am not spending any additional time in scanning the slide with an additional objective. This is essentially the preview scan that you get from your preview camera. And so it detected the hippocampus, and it named them 1, 2, 3, 4, 5, 6, all the 6 regions. And now what it's doing is it's scanning. So essentially, it's going through that process of scanning. And if you're familiar with that process, it's going to lay down these focus points. So it goes from the coarse focus, then you can see it's right now in the fine focus step. And I've run this slide so many times. It takes around 1 minute and 52 seconds for this whole scanning process to be completed. So while we are waiting, very soon you will see that I can expand this tab for acquisition monitoring. So if you're familiar with the Axioscan 7, it allows you to see live the regions that are being scanned. So while it not only detected just the hippocampus, it is scanning just those regions as well. So once the scan is completed, now you can go to viewing each of these individual sections that were detected, right? So each of the 6 scenes. And for me, just seeing individually each of those 6 scenes that were detected scanned, that's seeing is believing, right? So you have on one end, it detected the entire tissue, versus using an AI model that you can incorporate in your scan setting and scan profile. You can just detect the individual subregions and then scan just the subregions. Of course, you can then start thinking about what we have done is you can set a Z-stack. You can collect an entire stack of those subregions and then do beautiful 3D rendering of the Golgi stain neurons as well. So hopefully that gave you a good workflow glimpse of how you can detect just subregions. So let's look at another example of me looking at fluorescent sections. So in this case, these are slides that are very faint. As you can see, these are fluorescent sections that are not stained with any dye. Again, very difficult to scan unless you try to adjust the histogram and try to squint your eye and try to draw them out, or do a DAPI preview scan, or use a Sharpie, so on and so forth. But now that we have access to AI and all of the image analysis settings that you can create, basically all you do is collect as many preview images as you can from each of your slides. So if you have 50 slides like I had in this particular example, I collected all the preview scans and I fed them into our ZEISS cloud platform. And you basically tell the program what is your background, and then you tell a class that is your region that needs to be segmented, give it a color, and then train it. Retrain as long as you think that the outcome looks really good for you, right? Visually. So it's not picking up any background other than your tissue. So this what I've seen personally is the deep learning models that we utilize on the cloud platform does so well on slides that have bubbles, that on slides that are not mounted so well, right? So there is, if you have the cover glass not mounted so well, which is, let's face it, that's reality. Not every slide is going to look so great. So bubbles and anything that's on your slide that you don't want the tissue detection method to pick up, and you don't want to be spending time screening through these slides, right? So in my personal experience, I've seen that these models that we create on the cloud by far work the best in terms of avoiding all the bubbles, because you are just training them on your tissue or regions of interest. So once you have a model of that sort, then you can use that model that you create and incorporate that model right into your scan profile. So in your scan profile, you will see a drop-down menu under the sample detection wizard where you can invoke or engage a very specific image analysis setting. So that image analysis setting essentially utilizes the segmentation model that we created on 𝗏𝗏s Cloud, right? So once you do that, it's now part of your scan profile, right? And using that model that I just showed you in the previous slide, where we utilized many, many different preview scans, we kind of were able to get to a almost universal model which works across both coronal and sagittal section. So this is very exciting, and I use the word almost because, like I said, if you if you heard me say earlier, the more images we feed, the better our models become, and that's been something we have observed. Like, so the more and more preview images I train, the better and better my model becomes, and the better my detection method becomes. So that's where we are at. And with this model that I said, I'm able to detect all of my brain sections just with the preview scans, right? So that's where we are at, and it's super exciting. So one more. Yeah, so this example was on a large format slide. So you might be thinking, okay, I don't work with the typical 1x3 slides. What about the large format? So you can use AI model once you have it. Once you have the image analysis settings set in your scan profile, you can apply that on any type of tissue slide, right, irrespective of the format. So that's an example of a brain section detected with an AI model. So the excitement doesn't stop just with brains sections. What's also very, very exciting is we have now started to utilize these AI models and see how does it perform across different tissue sections, right? Different tissue types. Yes, we had initial success with brain sections. These are really something many, many different labs work with. But what about retina sections, right? So as you can see up on the screen, the slides on the left, lot of bubble and then mounting issues, right? So the way you mount the cover glass, there's a lot of space and bubbles. So it picks up all of that. It picks up all of that with the analysis setting that we initially used, and also your regular threshold-based detection. It picks up all of the cover glass edges, and then as a user, I have to go and clean this up, right? So on the right panel, what you see is where we've used custom sample detection, and for short, we just call that CSD, the module. With that, the erroneous detection that you see on the left side is all cleaned up, and you just see the retina sections, which is fantastic. So this is by far, retina sections are not easy to detect. We have utilized DAPI preview previously to detect these tissue scans. But now seeing the result with the AI models generated on the cloud platform, it appears to me that I personally would just transition over to utilizing just image analysis for detecting tissue sections. And one last example that I want to leave you with is this example comes from slides using a marker and a scribe, right? So this basically, we received slides which had tissue sections, but the user utilized a diamond scribe and then cryo sections laid on the slide, then another Sharpie mark to utilize the marker method. Now, having seen the excitement with AI and seeing how it's doing so well with tissue detection, we challenged ourselves and we told the customer and the user, maybe we'll take you away from the pain of having to, use a Sharpie for all of these slides. So let me show you in this particular example where we have an image analysis setting based on machine learning. In this example, it was IntelliSys using the module. But what you see is the Sharpie in black around those tissue, but we utilized a fluorescence, which was 𝗏𝗄𝐶 on these sections. And with that image analysis setting that you see under utilized in the sample detection wizard, we were able to just delineate just the tissue. Now, there are many different ways of detecting these tissues with AI or image analysis setting. As in, we also have other contrast methods such as 𝗏𝗏. You may have heard of 𝗏𝗏. That's available on the Axioscan 7. Or you could be utilizing other fluorescence channels, right? So it does not restrict you from utilizing one contrast method or the other. However, instead of using just the threshold, I'm able to use those pre-scans and then feed those pre-scans to the model building platform. So we also have another very promising and exciting method for tissue detection called the bright field pre-scan method. Again, you can have these pre-scans come in any different method. However, rather than having to go through the traditional route of tissue detection, we can now utilize these pre-scans and start training our regions of interest on the cloud platform, utilize those models that are based on deep learning, you name it, utilize those models, engage them as an image analysis setting within Zen, and scan slides using these scan profiles. So with that, I think I am done showing you some of the exciting examples, and I want to end with this slide, letting you know that we have many workshops coming up. So if anything that you saw gets you excited and you want to learn more on how would I go about doing this, because today we looked at many examples, right? But if you are curious about, okay, that's good, but how do I actually do this on my section? So if you are curious about that, please sign up on one of our upcoming workshops. The QR codes are up on your screen. If you have your cell phone, you can open up your camera, take a picture. It will take you to those websites for the workshops. And if you also require training on any of these many different modules and workflows and just learning how to utilize the instrument, we have ZEISS portal. ZEISS portal, if you are able to log in, it is your one-stop shop for everything you need to know about your ZEISS instrument, training resources, videos, and yes. And the last QR code I have to mention is for our upcoming live streams. So this was our third session, and we have many, many exciting ones coming up. So please do join us. And thank you so much for joining me today. And I think at this point, I'm ready to take any of your questions.